All right, this is Miss Moore's chapter 15.7 from Math 102, Functions with Radicals. So we want to recall from Math 101 what the domain and the range are in our function. So the domain of a relation is the set of all first coordinates. Okay, so essentially it is the x values in our xy ordered pair, okay? And then the range of the relation is the set of all second coordinates. In the relation. So essentially those would be the y values, okay? So the first thing that we're going to do is learn how to evaluate a function. And when we evaluate a function, we are simply replacing the value for x in that function. So this right here in the parentheses is our x value. You have to pay attention in HAWQs and notice how they're asking you to express your answers. In this one, they are asking you to express your answers in decimal notation, and you're going to take out your decimal to 4 decimal places. So we are going to start by finding h at negative 8.5, and we're going to substitute negative 3 times negative 8.5 and then add 1. So when I take negative 3 times negative 8.5, I now get this to become 25.5 plus 1, still under the radical. And that gives me the square root of 26.5, which I'm now going to figure out in my calculator. Oops. Square root of 26.5, and I get 5.14781. And so to round it to 4 decimal places, I would finish it off with the 8. Okay, now the next one, they're asking you to express it in radical notation, which means that we don't want decimals, and we're going to take out perfect squares actually in this case, we're going to take out perfect cubes in this radical. So looking at g of negative 12, I will get the cube root of negative 4 times negative 12 plus 1, which is the cube root of 48 plus 1, which is the cube root of 49. And that, don't think has anything, no, I don't think that has any perfect cubes in there. So it's a perfect square. And so I would just leave my answer like that. Okay, so that should be in radical notation. Now, with the domain and the range of a function, you are going to be expressing these in interval notation, okay? So if the point is included, you will use a bracket, okay? One of these. If it is not included, then you will use the parentheses. So if your arrow is going in a direction, you will have an infinity in that aspect, and that will, the infinity will always be hugged by a parentheses, not a bracket, okay? So I like to do some shading on this when I'm looking at this. Basically what I'm looking at all the x values in the domain. So I start at where the x is, okay? And I just kind of go here. This is the first x that it hits, and I'm going in this direction. And so every x value that is to the right of -3 is going to be included. So when I write that domain, I am going to start at -3, and there's a dot on there, so that means that -3 is included. And I'm going to go to positive infinity, which means that the arrow goes on and on and on, okay? And so that is from the x value. Now the range, and I might want to write this, these are the x values. The range is the y values. And so now I'm going to shade it in a different color. Whoops, I'm going to erase that. Shade it in a different color. And so now I'm looking at everything. The first y value is right here, and everything above that axis. So, I mean, the shading looks a little bit the same, but the y is above the x-axis, and then the x goes from the -3. So the lowest y value that will be on that graph will be a 0, and it's included because the first point is -3, 0. So 0 will be included, and then it will also go to positive infinity, okay? Now, the zeros are also known as the points where it hits the x-axis, so where the y value is 0, and we also call that an intercept. So my 0 in this function is going to be when x is -3. So my 0 is -3, 0. Now that's an ordered pair, so we don't put brackets around that. So we want a point that's going to be the -3, 0. Okay, so we're going to try another one. And so again, the domain is going to be from this x value on. Okay, so it's going to cover everything from that x value, and it's going to go below because that graph just keeps on going. So my x value is going to include, again, it's going to be -3 to infinity because that arrow tells me that it's going to go on. So every x on the x-axis, starting with and including -3, and then going to the positive infinity direction, is going to be included in the domain. Now we're going to look at the range, and the range is the y values. So the lowest y value I have is going to be at 0, and if I look at the y-axis, it's going to be 0, but this time it's going down, and it's going to go to negative infinity. So we include 0, and now we go to negative infinity, okay? The zeros in this are also going to be the point that sits on the x-axis. So we will have the point -3, 0. All right. Now we're going to determine the domain and range. Actually, we're just going to be determining the domain of each rational function. And so remember, the domain is always the x values. We're going to use interval notation, okay? Interval notation. So that we're going to be using either parentheses, again, if it's not included, and brackets if it is included, okay? So what you want to do is you want to, when you're looking at a square root, okay, so remember that square roots cannot have negative radicands, okay, which means the number underneath the radical. We can't have negative radicans, so that means that we have to set the radican. It has to be anything greater than or equal to 0, okay? So in a square root, set your radicand greater than or equal to 0 to find the domain, okay? So in this one, I'm going to take negative 5x plus 3.6 greater than or equal to 0. And then I'm going to solve it. So when I solve it, I'm going to subtract 3.6. So now I get negative 5x is greater than or equal to negative 3.6. And then I'm going to divide by a negative 5. And remember, when I divide by a negative in an inequality, I must reverse the sign. And so when I take 3.6 divided by 5, negative 3.6 divided by negative 5, I get 0.72. Okay, so let's think of a number line here. Okay, so that's my X number line. I am coming from, because this arrow is pointing to the left, I am coming from negative infinity, and I'm going all the way up and including 0.72 on the number line. So when I write my interval notation, if I read this left to right, I would start at the negative infinity, and that's going to obviously have a parentheses around it. And then I would go all the way up and include the 0.72, which means that it would have a bracket on it. So how I write this is the following: negative infinity up to, and including 0.72 with a bracket around it. So anything less than or equal to 0.72 would give me the domain of this rational function, okay? Now, with a cube root, we can take the cube root of a negative number, okay? So you can take the cube root of a negative radicand. Therefore, the domain of cube roots is always negative infinity to positive infinity. It will include every x value, okay? So, you know, when you're looking at, if you were to go into a graph and you are looking at the cube root of something, okay, whatever that is, you could see that it would include every single x value. So for the cube root, so basically what you have to do when you're looking at this is you have to check out the index. If the index is odd, 3, 5, etc., if the index is odd, then your domain will always be negative infinity to positive infinity. If the index is even, such as this first one that we did where, you know, we know this is a square root, then we have to set our radicand greater than or equal to 0 to see what the radicand has limitations to. So that finishes up 15.7. You guys can always email me if you have any questions at this email. Just tell me that you are one of Miss Moore's students, and I would be glad to help you if you had questions on your homework.